very much. Now, first thing, I want to first apologize. I landed back from the US on Monday. I am jet lagged like hell, and I know how bad the jet lag is because I still have USD in my wallet. So, I first and foremost go, I seek your apology, and I hope you understand that if I slip up, it's just because I have jet lag. Right? Now, Dandelions, I'm going to change the format of the presentation a little bit. I'm going to talk to you about my customer's problem first, then what the customer needs, and then I talk to you about what I'm doing. Alright? And in that sense, I'm going to start it off with a disaster. Alright? And I actually generally mean disaster, not as my presentation is a disaster, but we're going to talk about disasters. Alright? So this is the map, June, of the thermal map of the world. As you can see, everywhere in red is 35 degrees and up, everywhere in yellow is 45 degrees and up, and this is why we are burning. And everyone knows about the fires, the bushfires that we're all facing around the world. So if you talk to the people who are in the yellow zones, right now, they are very concerned about it, obviously. So what makes society work, from this perspective, is we have infrastructure. You know, the multiple layers of infrastructure that makes life work. But in a disaster environment like fires, floods, hurricanes, all this goes away. And the first people that are on site to deal with that are the first responders. So they were asking a lot of hard questions. And when you talk to a first responder who's dealing with an environment like this, they actually tell you there's no infrastructure. So here's the question. How do you get anything done when there's no road access, there's no power, and no comms? Take these three away, civilization grinds to a halt. But for a first responder, they must act. So in this situation, they need to get one thing working first, beyond all else. And it is this one, the phone. Because basic relationship advice, without communication, nothing works. I'm sure nobody can disagree with that, right? And if you disagree with that, I'm very sorry for you. So when we speak to them, they went, okay, we like what you're doing. What can we use it for? On the left, here's search and rescue. If we can find your phone signal, we can find you. And on the right, we can drop cell towers into a disasters, like fighting the fires. They can have broadband internet access while fighting the fire. Because they're right now fighting without those services. So what did we envision? We said, all right, let's try this. We're a space conference, right? I'm a space geek too, like you guys. So we're parking a cell tower in orbit. The idea is we'll drop it from orbit, survive re-entry, open up, lands. Opens like a flower, solar panels, cell tower, sat connection, sensors. And we call this a gyro chute. And we first got working on the idea because like, really you want to drop stuff from space? We actually figured it out. And so instead of like me explaining to you what a gyro chute looks like, how it works, I'll just show you. No plants will harm in the making of this video. I want to be out there for any of you who want to make sure the plants are safe and sound. So, thing doesn't always go as planned, but things go well. This is our gyro chute. You can think of it like a ceiling fan falling from the sky. And the faster it spins, the slower it falls, using a process called auto-rotation, which is basically aerodynamic braking. In this test model that we're doing for the New South Wales SBIR, we've already put in a satellite connection with a Wi-Fi hotspot. And once coated with solar panels, it's good for year-long operation. So this is what they go, wait a second, you can now get us internet in the middle of a disaster? People pay attention now. So we actually ended up with, we're filing the patent for the world's first air deployable telecommunications network for them, where we can drop and get comms running in a disaster in under 2-3 hours. For you guys, which is your space people, I'm basically building an orbital re-entry vehicle for time-sensitive deliveries, and my first customer just so happens to be dropping cell towers for the emergency services. Now, they did make one request that drove me a little nuts, right? And this is the part where I had to go, please, Borata Seed, I need your help. And They asked for one requirement, and as a customer, yes, we will make sure that happens. They asked for biodegradability. So customers, yes sir, when I'm talking to you guys, what the heck did they ask for? Biodegradable spacecraft? Not necessarily the easiest thing. But we did look into it, and we actually figured out that there is a possible way of doing it. So what we're flying on Water C is a biodegradable composite. So this is actually testing, it's ion thruster, and that's the simulating re-entry. We actually realized that we have access to a biodegradable composite that's suitable for spacecraft manufacturing. It sits somewhere between strength and weight between aluminum and carbon fiber, not as light as carbon fiber, not as heavy as aluminum, so strength is in the middle, but it biodegrades. And for our purposes, it's also RF transparent. And so, while most of you may not consider that a concern, because we're dealing with comms towers and sensors, this matters. So we can actually protect sensors in a disaster. So, funny enough, we're working on the first biodegradable spacecraft, and I don't know whether that's useful or not. But that's what the customer asked for. So, this is our Water C mission. We've done all the testing. So right now we are actually doing a 3-point bend test in space. Water C is going to fly it. This is our firmware test. We're making sure all the coding is done correctly. We're actually going to push and pull on the materials, also these 4 corners, so you can see how it works. In terms of all the opportunity, and I want to say thanks to Ivor for helping me do Water C and getting me to win, because that also got me attention to talk to other people. The folks in agriculture go, we like the idea. Hey, we can sell you stuff in the space industry? Oh, well, they also want comms to do autonomous farming, right? I've spent emergency service, I mentioned that to you. Folks in environmental monitoring go, I can deploy sensors while minimizing my environmental impact and damage. I'm paying attention. And defense goes, I like what you're doing. Can't tell you what we like it for, but please come and apply. And that's my presentation in a nutshell, folks.
Excellent, Brian. Do we have some questions? One at the back.
Hey, it's John from UNSW. So how do you control the downrange positions of something re-entering an autogyro?
Really simple. It's a spinning blade, right? So when the correct wing is at the correct position, you flick it. And then it will just create the momentum force to make it angle and go in each direction.
Individual pitch control, isn't it?
Yeah, that's what we're working on right now.
Quite difficult.
Yeah. And we are aware, and we're like, so we'll work on other things too.
Yes.
With regards to the biodegradability, how did you look for that material that do what you want to do, but also biodegradable?
Like, how did I find it?
Yeah. Is it off-the-shelf materials or it's already manufactured? Yeah. So how do you search for that material?
We found suppliers overseas that have parts of the technology that we need, so we sort of like cobbled it together. So thank God we have the suppliers helping us. The resin they're using is not biodegradable yet, so we're going to work on that as well. But the material base is, it meets the requirements already, so we shouldn't have too much difficulty making it biodegradable. But that problem with that biodegradable version is increased oxidation. So the oxygen issue, the same thing we were talking about, forgot how to pronounce it. So we've got to work through that too.
And does cost come in as well?
It is costly, but the customer goes, we're willing to pay for it, because the difference for them is logistics. If I drop this out there, there's a cost to recover. If I don't have to recover the airframe, but just electronics, that cost difference is worth it already for them.
Yes.
Trying from Global Systems. So when you deploy these cell towers, would they be using the existing telecoms infrastructure, or would you be using a dedicated part of the spectrum to provide these services?
We are actually talking on all of the above cases with the suppliers. So Telstra, Optus, New South Wales Telco Authority is talking with us. So their request is the P25 radio network push to talk, right? So that's the frequencies they control for the emergency services, so we're operating on that. And for the cell services, we're working through it.
softer areas or advanced areas, and presumably you're looking at some of those.
Yes, in fact, one of the conversations that's not in this presentation is actually orbital returns. So if you want to think of SpaceX Starship as the 40-foot shipping container, who's going to be the FedEx overnight shipping? And we realized that we have an opportunity to play in that part. So we're talking to folks around orbit manufacturing, fiber optics manufacturing, who want to do it in orbit, and using this craft as a way of bringing it back.
I think we need to move on.
Okay.
Thank you very much.